Hey, it's time! Video note 6.2, types of reactions and predicting products. So let's get busy. Make sure to read chapters 6 and 7 of your book because 6 tells you all about balancing and stuff, and 7 has the different types of reactions. So, hey, you can already do this, but just to remind you, there's 5 types of reactions: combination, decomp, single replacement, double replacement, and combustion. Okay, so how do you recognize them if you just see the reactants? Well, in combination or synthesis, there's only going to be 2 elements as reactants. In decomposition, there's only 1 reactant total. In single replacement, you're looking for an element in a compound. Double replacement, you're looking for 2 compounds, and they're going to be ionic. Oh yeah, ionic. And in combustion, you're going to be looking for a hydrocarbon and oxygen gas. So, synthesis, let's put it together. Synthesis, let's combine it. Yeah. So 2 elements combine in synthesis. Elements make a compound. All right, it's only 1 product. So what kind of synthesis reactions might you see? Well, the element sodium and the element chlorine make NaCl. But wait, why is it NaCl? And because there's 2 chlorines over here. Well, first let's talk about why there's 2 Cl's over here. Remember, chlorine is one of the non-cool So chlorine's diatomic when it's an element. And being even more specific, because it's a diatomic element, it's one of the gases. Sodium is a solid metal. But when you put them together, you get NaCl. Why just NaCl? Because you got to cancel charge. Na from the periodic table plus 1, Cl from the periodic table negative 1. When it's an ion, put them together as 1. Okay, 1 to 1. And then that's an ionic compound. So it's going to be a solid here. And then we would go back after we have predicted the products, put in the states, we're going to put in the coefficients to make it balance. So I needed 2 there to get 2 chlorines on that side and 2 there. Hey, look, it's hydrogen and bromine. What are those elements? Yes, they are. Hydrogen is a gas at room temperature. Bromine is a liquid at room temperature, but they're 2 of our diatomics. Look, the Br and the of Nafkulbri. But why do we put them together as HBr? Because H has a +1 and Br has a -1. That's why it's HBr. And we'll just say for now that it is liquid. All right, that one I wouldn't have you do. So, synthesis, put it together, make 1 compound. Combine it into 1 combination. 1 combination, 1 thing put together. Okay, hey, look. It's an element and another element. Let's put them together. So check your periodic table, find sodium. It's a +1 charge. Sulfide is a -2, so we need 2 sodium and 1 sulfide to make this compound work. And then, and only then, do we go back and balance the equation. So I need a 2 there to make it balanced. All right, sulfur is a solid at room temperature. Sodium's a metal, it's solid. Sodium sulfide is an ionic compound, it's also going to be solid. Hey, look, it's lithium and fluorine, 2 elements. Save that one and this one, and we'll do those in class. So, how do you recognize synthesis? Only 2 reactants. What do? Put them together and cancel charge. All right. Look, it's the next type, decomposition. So what happens in a decomposition reaction is that 1 compound breaks up into smaller pieces. Those smaller pieces for us will be elements if I ask you to predict it. But you should be able to recognize any decomp reaction because they're starting with a compound. Compound, compound. How do you know? Because 2 elements are combined to make this compound. All right, so what does this compound break down into? It's elements. Why are there 2's there? Because they're 2 of the super 7, Nafkulbri. So then after you do that, you would go back and put in coefficients. So we're going to need 2 of those and 3 of those. Okay, CO2 is carbon dioxide. It's a compound. Only 1 reactant breaks down into the elements carbon and oxygen. This is a diatomic, that's why there's a 2. Carbon is not diatomic. Okay, and then we would think about states of matter. Gases, gases, solid, carbon, gas, and carbon dioxide is a gas. Okay, so we'll keep practicing. Oh, what is this all about? Decomp. Look at the zombies. Like their arms and legs and stuff can fall off because they're zombies, right? They decompose, break into smaller pieces. Bye, zombie. Okay, look at, here's some reactions. They're all decomp. How and why? Whoops, who puts that? Decomp only 1 reactant. Reactants. All right. So, oh look, this is 1 reactant. How do I know? Look at that big old thing. There's no plus sign, so there's not 2. 1 reactant, 1 reactant. Break it into its atoms. Mercury and oxygen. But wait, oxygen's a super 7, needs a 2. N and H. Whoops, that's not an H. Who does that? N and H. But then remember that N is the N in Nafkulbriha and H is a in Nafkulbriha. Okay, save these two in your notes. We'll do them in class. Oh, hey, look, nitrogen dioxide decomposes. What kind of reaction is that? Well, let's write out the formula. Nitrogen dioxide. It's a compound, decomposes, breaks into N and O. But then you ask yourself, self, are they super 7? You betcha. Calcium reacts with oxygen. Calcium reacts with oxygen. Oxygen is a diatomic. What's the only way these can go together? Well, calcium's in group 2, so it's a +2 when it's an ion. Oxygen's in -2 when it's an ion, so it's CaO. And then you would go and balance it. Okay. Save these two, and we'll do them in class. So I'm doing a couple in the notes, and we're going to pick up the rest in class. Hey, it's a new kind of reaction, single replacement. What the heck is going on in single replacement? Well, you hopefully already know that an element and a compound are the reactants, but you get a new compound and a different element as products. Okay, think about single replacement as, hey, my date left me for somebody better looking because they were more active, but it only works if they're more active. What does that mean? Use the activity series. Okay, so here's your element and here's your compound. If your element's a metal, you would look to see if it could kick out the metal in the compound. So then you would look to see if C metal is higher than A metal. And guess what? It must have been for this reaction to happen. Okay. If your element is a non-metal, you would look to see if it's higher than the non-metal in the compound to see if it can kick it out. You have to use the activity series. So, oh, look, we're a happy couple. But then, I'm more active than you, so I'll kick you out. You've been replaced. And now I'm Jen and I'm single. But hey, it's okay because she can handle it. So the thing that's more active will kick out what it can replace. Single replacement. A single thing replaces part of a compound and kicks out something else to be single. Kick it out. Okay. Hey, what do you got to look at? These activity series is. Okay, so here's the activity series for nonmetals. Here's the activity series for metals. So, oh, look, single replacement, element, compound. So you got to find K because it's by itself to see if it's a kicker outer, if it's more active. It's a metal. So it can only replace the metal if it's more active. So is K higher than Na? It is. So goodbye sodium. I'm by myself. I got kicked out. But that leaves potassium with chloride, and you got to cancel charge. K is a +1 as an ion. Cl is a -1. KCl. All right. Hey, look. It's tin all by itself, element, and aluminum bromide, compound. So you have to see if tin is higher than the metal aluminum. So where's tin? Tin's right here. Aluminum's up here. No way. No reaction. Why? Because tin is not more active than aluminum. So tin cannot kick out aluminum. Element, compound. So you look to see if the element, bromine, is non-metal higher up than iodine. So here's bromine, here's iodine. This is going to work. Bromine goes in and kicks out the iodine. Goodbye, iodine. You've been kicked. Why did I put a 2? Because iodine's diatomic. And then I got to get lithium and bromine together and cancel charge. Li is a +1, Br is a -1. It's LiBr. All right. What do you do after that? Well, then you have to balance the equation. And I know I haven't been doing it for all of them. But let's see. I need a 2 there. And a 2 there. And then we're balanced. Okay, so step 1, figure out what the type is. Step 2, see if the one by itself, the element, is higher up than whatever it's trying to kick out. Metals can only kick out metals. Non-metals can only kick out non-metals. Save that one, put it in your notes. We'll do it. Okay, double replacement is like soap opera chemistry, square dance chemistry, changing partners, but everybody still has one. And then remember this, once in front, always in front. So there's AB compound, CD compound. A and C do the switcheroo. So that A is with D, oh look, and C is with B. But once it's in front, if it's in front in the reactants, it can only be in front in the products, okay? Because they represent ionic compounds, and they have to go with cations, have to go with anions. So the first part do the switcheroo, the cation switch. Okay, and then you have to remember to cancel charge to make your compounds. So also important, note that in a double replacement, the reactants are aqueous, AQ, and one of the products needs to be a solid or water. So if it's water, you're done. But if it's not water, you got to figure out which product is solid. So you have to use the solubility rules. And swing your partner round and round. Do-si-do, double replacement, square dance chemistry. Okay, so here are the solubility rules. You have to be able to use these. And the way you read it is, if something is soluble, that means it dissolves in water. So that's AQ, all right? If something's soluble, it dissolves in water, AQ. So any nitrate, acetate, or chlorate is soluble. Any compound with those ions in it will dissolve. Any compound with these ions in it will dissolve. Any compound with these ions in it will dissolve unless these ions are with these metals, okay? So this is the mostly soluble chart, and this is the mostly insoluble with a few exceptions. Let's practice over here, AgBr. So you're looking for anything that has silver or bromide. Oh, look, it says bromides, but then it says soluble except with silver. This is silver bromide, so it should be soluble when it's a bromide, but because it's with silver, it's going to be a solid substance, solid, okay? Soluble means AQ, dissolved in water. Insoluble means solid precipitate substance, okay? So let's do one more, and then we'll practice in class. NH4Cl. Let's see. Oh, any compound with ammonium in it is soluble in water, so that would be AQ. All right, we'll practice in class. Solubility rules. You only use this for double replacement, double replacement. Okay, so what's a precipitate, you're saying? A precipitate is a solid substance that forms when you are mixing two solutions. Okay, S stands for solid, AQ stands for aqueous, dissolved in water. S is solid, it means not dissolved in water, insoluble. So you have to use your solubility rules. Hey, Kool-Aid, hey, what? What do you got? I have soluble substances, so everything in me is aqueous. Did you hear Kool-Aid talking to you? Okay, so here's some samples. Sodium chloride reacts with lead 4 nitrate. Sodium chloride, Na plus 1 minus 1, Cl. All right, it's a reactant. The reactants in double replacement are aqueous. Lead 4 nitrate. Lead, Pb, oh, it's plus 4. I didn't even have to look. Nitrate, NO3 negative. So Pb, NO3, 4 of them. Why? Because I have to cancel charge. All right, so what will the products of this be? Well, we got to do the switcheroo. Sounds fun. Na goes with NO3. So I have to cancel charge a negative 1, a positive 1. NaNO3. Plus, I'm going to do it, I'm going to write down here, plus lead has to go with chlorine, but lead's a plus 4 in the reactant, so it's got to be a plus 4 in the product, plus 4, negative 1. PbCl4. Now we have to go back to our solubility rules and decide which one of our two products is going to be the precipitate. So I go all the way back, and I'm looking for lead. I'm looking for chloride. Here's chloride. Chlorides are soluble unless they're with lead. Oh, that's lead 2. Also lead 4. Ooh, who forgot lead 4? I forgot lead 4. Okay, so lead 4 chloride would be insoluble. Okay, and then we could check anything with sodium is soluble. So let's go back. All right, so this is going to be the solid precipitate. Anything with sodium is aqueous. All right, save these two. We'll do them. Okay, combustion. Hey, so this is the last of the 5. Combustion, what do you think of? Well, I think of Elvis Presley, of course. So here's what you need to know. Combustion is burning. That needs oxygen as fuel and oxygen to burn the fuel, hydrocarbon. All right. The cool thing about the products for combustion is that they're always carbon dioxide and water, CO2 and H2O. Okay. So when you recognize a combustion reaction, you'll know the products automatically and realize that they're both going to be gases. Why? Because they're coming off of something burning. So they're really is that your lab? Is somebody burning their lab? Stop it. No. Okay, so here's some samples. Methane burns. CH4 is methane. And I'll tell you it's a gas. All right, that one we'll have to get used to. But you got to make it burn. So you have to put the oxygen gas. All right, and what do you get? You already know it, CO2 and H2O. All right, so first you put the correct formulas in. All right, that's the formula for carbon dioxide. Can't change it, that's water. So then we'd look for coefficients, and we'd have to balance it. We have 1 carbon, 1, 2, 3 oxygen, 1, 2 oxygen. Ooh, 2 hydrogen, 4 hydrogen. So I'm going to do hydrogens, and I have 4 on that side, 4 on that side, and I have 2, 4 oxygen, 2 there, done. All right, we'll do this one in class. All right, so how do you know what states of matter to put? Remember this. These are most important points. Metals are solid unless it's mercury. All right, so if you have an element that's a metal, anywhere in your chemical reaction, put an S next to it. Unless it's mercury, put an L. The diatomic elements, anywhere in your reaction, reactants or products, put a G next to them if they're in their elemental form, unless it's bromine, which is a liquid, and iodine, which is solid. Now, remember this for ionic compounds. Ionic compounds are solids when they're decomposing and when they're combining. They're aqueous when they're reactants in double and single replacement. But you need to check the solubility rules for products in double replacement. And then combustion gives gases. Woohoo! All right. Hey, what are these? Predict products, include states, and balance with coefficients. We're going to do these in class, so write them down. It'll make your life easier when we get to class. Finally, here's a review. Combination makes one product. Decomposition, one thing makes two. Single element compound, the element tries to kick something out, but it can only kick out what it is the same as. Metals can only kick metals, non-metals can only kick non-metals. Double replacement, the old switcheroo, cation switcheroo. Combustion is element and compound, but the element is oxygen, the compound is carbon, and so it turns into carbon dioxide and water. This link is on the website if you want to look at some more information. So, to review, make sure you recognize the type of reaction. If you're writing a product that's ionic, cancel the charge. Okay. Use the activity series for single replacement. Use solubility rules for double replacement products. And combustion, carbon dioxide, water, and know your diatomics. So, we'll keep burning. Here's some more keys to success. In synthesis, cancel the charge for products. Woo! In decomp, look for diatomics. Single replacement, use your activity series. Cancel the charge. Woo! Double replacement, cancel charge, and get a precipitate. All right, by always, I mean always, unless you get water. Woo! I love Elvis. All right, so make sure you can do all of these things now that you've seen this video note. Thing. Anyway, hey, I got through it with no trains, but I think it's long. So anyway, have a great day. See you tomorrow.